Okay, thank you so much for joining us, everyone. We are just going to get started in another couple of minutes. Thank you for your patience while our panelists are just joining in, and other attendees are joining in as well. Just give us a couple of minutes. We are very thankful for all of you who have joined, and we are quite excited to be hosting this session today with all of you. Varun, I think we can get started. I'll try to coordinate with Namita ji once she joins in, but so far I haven't heard.
Got it. And Nat as well, right?
Yes, Nats is joining in. Yeah.
Fantastic. Great. I think we can get started. Thank you so much, Shardul, and thank you to the panelists for being here before time as well. Welcome, everybody, to this first webinar that we're hosting at the Institute for Climate Innovation. It's titled From Academic Research to Industrial Applications, Approaches to Climate Innovation Commercialization, which is a bit of a mouthful, but the problem that we're biting on right now or thinking about is also a bit of a mouthful, to be honest with you. It's a wicked problem that has existed for really decades and continues to persist today. The question is really about how do we take world changing transformative innovations that could be being developed right now in labs across the world and in India and the developing world, especially, and make them fit for purpose for scale, right? Through whatever structures might need to exist across science, industry, and policy. We have a wonderful set of panelists that are going to discuss these questions, many of whom are actually actively working on these things and implementing these transformations in society across these areas, whether it's ventures both on the VC side as well as entrepreneurship, whether it's industry in large corporations, whether it's academic research and technology translation environments, and whether it's on the policy side as well. So we're very excited to have all of them with us here today. My name is Varun Deshpande. I'm the founder and executive director of the Institute for Climate Innovation. And our mission statement, I'm going to go a little bit into kind of what we do and why we felt this was something that's worth discussing today as kind of our first event that we're doing. Our mission statement is to kind of build sustainable abundance with next generation climate innovations. The reason that we want to do this is because when we take stock of what's happening on the road to solving climate change, there's actually a lot of good news, right? I mean, we hear about it all the time. Renewables are a huge success story. We have greater than 30% of electricity generation as of a couple of years ago already coming from renewable energy. And the other big success story that we see is electric vehicles, which have proliferated throughout society. So in 2025, globally, 1 in 4 new vehicles will be electric vehicles. And we see this take off in every new country where interventions are implemented to enable their takeoff, which is really exciting. It's important to note that the technologies that underpin some of these successes were not always mature, right? So something has happened along the way to enable these categories to take off so that we can say that we're making a lot of progress towards solving climate change. So if you look at solar panel prices, if you look at lithium ion battery prices, they've really come down over the decades. And there's really been an intervention cascade that comes from both government as well as private industry, and of course, science as the interplay between those two. Now, based on the success that we're talking about, really what should be happening on the journey to, quote, solving climate change is this, right? So this is an IPCC projection of what should be happening by way of net and gross emissions. And you'll see, towards the end of this time, there's direct air capture. In the meantime, there's probably the decarbonization of existing industries, etc. But what's actually happening, and you don't have to pay attention to the specific numbers on this graph right here, but what's actually happening is that per capita emissions are actually going up, right? You'll see it go down in the more developed economies over time, but in developing economies, of course, you will see it go up, especially in a place like India. And this is kind of how we get to, in 2050, a trajectory of global emissions, which is totally different from what it is today, right? So the US, which we know to be the biggest emitter in the world, or China and the US, that we know to be the biggest emitters in the world, the US will reduce in its relative emissions for the world to about 6%. The EU will go way down to about 3%. And then the regions in which many of the people who are on this webinar watching this live are going up. So India within that rest of the world picture is something on the order of 18 to 20%. Although if I had to bet, given rising incomes and industries of the future, etc., it might be more than that. Now, we might argue, look, that's actually totally sensible because we have 1/6 of the world's population. We still will in 2050. So why shouldn't it be this way? But the reason for us to re-examine this picture and think about how we can move in a different direction is because we're particularly vulnerable to the impacts of what I'm describing. And we all know this on this call. I mean, we see these adverse weather conditions, we see these catastrophes. They're sort of signs of the future arriving early, right? And there's major downstream effects of them. I mean, I think we're all getting a sense now of, ecosystem collapse, agricultural yield curves. If you look at, 52 degrees centigrade temperatures in the north of India now in the summers, and you look at the yield curves of some of the crops that we think are very hardy, like things like sorghum, etc., they really drop off a cliff beyond a certain point. Water scarcity in many of our cities, economic stress, poverty, health impacts, climate migration, political strife, etc. And we've seen what this looks like. This is a picture of the lakhs of people that were migrating internally within India during the COVID-19 pandemic because cities had come to a standstill and transportation had come to a standstill. So people really had to walk hundreds, if not thousands of kilometers to get back to their villages and figure out ways to survive during that time. Now, the reason for what we're talking about on the climate side is everything that we do as a civilization, as a species, generates carbon, right? So there's various ways of framing this. One is this Breakthrough Energy, which is a Bill Gates organization, and I know he's written some interesting memos recently that have been quite controversial, but I think this framing sort of makes sense, right? So it's how we power things, how we get around, how we make stuff, how we live, and how we grow food. These are kind of the big industries that form the lifeblood of humanity and of civilization. And we will continue to consume more and more of these as time goes by in countries like India, as well we should, right? That's what abundance means. Another way to think about it is what is India's current emissions mix, right? And you see a lot of the same thing that I just described. You look at some of the heavy industries here. Again, many of the panelists, many of the people on this call already understand this extremely well. This is from McKinsey, steel, cement, chemicals, etc., etc., agriculture, all of these things, transportation. So given that we have these industries that are the lifeblood of civilization that are contributing to the problem of climate change right now, but we cannot stop consuming or we cannot stop producing these things because we need them for civilization and for things to go on. And of course, we need them to continue to grow if we're going to achieve abundance. And that's a justice angle as well in places like India. Um, the assertion that we are making is that climate change is everybody's business, right? So the broad idea of how we solve climate change as an earth-wide project is to take some of those successes. We need to scale mature technologies, right? Like renewables, EVs, continue to scale them. And we recognize that there's some complementary innovation that's needed. The cost of storage needs to continue going down. There's geopolitics around critical minerals, et cetera, et cetera. We also need to invest in adaptation and resilience against the climate change that's already locked in, right? So like the agricultural yield curves and all the stuff that I was talking about earlier. And then crucially, and this is really why we exist as an organization and why we're having this conversation today, we need to invest in newer technologies at various levels of readiness, right? Including within some of those mature areas, but certainly there's a kind of a large landscape or a canvas of newer technologies which are not yet developed. If you look at the same McKinsey report's decarbonization pathways for India, you will see that in order to get to net zero by 2070, which is the plan from the government of India that everyone has sort of accepted, right? So if you look at net zero plans and roadmaps from large industries like cement, etc., they have also created net zero pathways by 2070, right? The line of sight scenario, which is the base case of what's already happening, doesn't get us anywhere close to that, right? We need to really move forward. And if you look at the right on the bottom there, we need technology breakthroughs that will help us get there faster. And this is the summary of our reason for existence, right? So 50% of emissions reductions that will get us to net zero are expected to come from technologies that are subscale. So some of them are still being developed in labs. Some of them are largely ready, but we need to kind of deploy them and scale them using existing toolkits or whatever may be the case. But the fact remains that we need to make sure that we're able to actually take these technologies and scale them and deploy them such that they're actually proliferating throughout society. So when we talk about these innovations, what do we mean? We mean ones that are transformative but are currently neglected within the landscape of science, industry, and policy. Those that move us along that path to net zero, of course, through the greatest emissions abatement potential, crucially address some of the needs of the industries of the future. So there's a lot of interest now in computing, data centers, etc. And that's going to create huge demands on our electricity systems and our energy systems, right? So we need to be able to power the industries of the future, right? And then interestingly, there's an opportunity now to create resilient sovereign capabilities that strengthen our strategic interests of the countries that invest in these technologies. And that's how we really think we will get to sustainable abundance. And I'm getting to the end here so that I can hand over to the panelists to talk about what we want to talk about today. But when we kind of looked across the landscape of what needs to move, and we'd be happy to kind of interact with any of you individually or as groups to talk about how we got to this landscape. We'll also be publishing a lot about these. We came across a basket of critical enabler technologies and their applications in the key industries or the grand challenges that I talked about before, right? So new energy systems, alternative fuels, carbon capture and removal, critical element or mineral processing, long duration storage, modernized power grids, industrial heat, etc. And then steel, cement, chemicals, aviation, maritime shipping, heating and cooling. This is obviously a very wide canvas. And I'd be happy to talk about specifics on what we're doing within each of these. Naturally, we're focusing on a few to start off with. And then, moving forward into kind of the topic of today, you'll forgive the slightly blurry graphic here, which I took from a wonderful paper. How innovation happens is really across this pipeline, right? So what we've been discussing is research and development is not just research and development. There is research, development, demonstration, and deployment. And that's how we get to solving the issue that we're talking about on this webinar, which is scaling technologies and deploying them across India and the developing world. And you really see that the actors who are fit for purpose for doing this are different at each different stage. And there's almost like handoffs that happen at each stage. Another way of looking at this, also taken from a wonderful paper, is thinking about different interventions and financing interventions that can solve things across technology readiness levels. So similarly, these low technology readiness levels on the left, all the way through to deploying and scale across this TRL scale from 1 to 9 and then beyond market readiness level. So in terms of our playbook, this is how we're thinking about solving these problems, working across science, industry, and policy, building ecosystems of support across those spectrum because that's what you really need, and inviting everybody to the table and sharing knowledge openly in the form of webinars like this, but we also do a lot of publication, work one-to-one with stakeholders and partners like the wonderful panelists here, etc. Our science programs are quite kind of robust and coordinated is how we're intending to build them out. So creating field-wide analysis and road mapping to set priorities, building coordinated communities, and we're going to talk about many of these things in the coming hour or so, or 2 hours or so, allocating and advising different types of capital, and then building networks of purpose-built R&D infrastructure if necessary. Similarly, policy support and international cooperation, so national and subnational policy support, either in the form of push interventions, R&D funding, or demand pulls, etc. And then crucially, we think systematic international cooperation, because a lot of the technology is global. So we need to advance the flow of that tech, capital, talent, knowledge, etc. And then just to close out here, It's important to note, and I'm not going to dive into these areas because it's just the backdrop for what we're discussing. But while we have systemic challenges that have existed for decades, which is how I opened this presentation, there has been major progress in deep technology sectors such as space tech, which we can look at, right? We can look at it as a case study. We can bring some of those same funders and those structures into new sectors, and we can learn from it. And crucially, we have a very exciting major transformation already of a lot of these structures that enable progress. So there is the new Anusandhan National Research Foundation, which many of the panelists might refer to or talk about. There's the new Research Development and Innovation Fund, which was announced by the Prime Minister a couple of weeks ago. It's a 1 lakh crore fund. And these are really, I think personally, these are new developments in India that are perhaps among the most important things that very few Indians, it's a rounding error. I mean, it's on the order of 0% of Indians know is happening, right? Because innovation has already changed the world many times before, including in India, and it will do many times again. And it's sort of incumbent on us, all of us, people in broader society, to figure out how to point that innovation at things that matter and things that can create a better world, possibly of sustainable abundance in the future. So, with that, I'm going to stop here. But I will say, please contact us for more information. Happy to work with people here as well as anyone that you think makes sense to work with us. Please reach out to us at india@climateinnovation.earth. And with that, I'm going to go into the first panel here today. We have a wonderful set of speakers. I'm not sure if all of them have been able to actually join yet, but I'll just do a quick round of introductions. Don't want to spend too much time on it. We have Sheel Kapoor, who's the Chief Executive Officer at the Foundation for Advancing Science and Technology, or FAST India. We have Dr. Abdur Rab, who's the Chief Executive Officer of India's Translational Research Initiative, or ITRI. We have Dr. Namita Gupta, who's the Senior Manager of the Foundation for Innovation and Technology Transfer at IIT Delhi. Dr. Vikram Vishal, who's a professor at the Department of Earth Sciences, IIT Bombay. Also the professor in charge of the Aspire IITB Research Park, and a number of different hats that he wears. And then finally, we have Nat Malupillai, who's the Chief Executive Officer of the wonderful IIT Madras Research Park. With that, I'm going to stop sharing here, and I'm going to dive into our panel here today. Just a quick note for the panelists: whenever you get a chance, please unmute, speak, and then mute yourself again, because that's how the webinar system works. So firstly, Sheel, I'm just going to throw to you because at Fast India, you're doing a lot of work on the kind of things that I discussed in that last slide, right? And I genuinely, personally feel that this is one of the most important transformations that's happening in this country. So some of the structures that I mentioned, ANRF, RDIF, etc. Could you speak a little bit to your work and kind of what's underway right now behind the scenes in India?
Yeah, sure. Thanks, Varun. First of all, a good morning and good evening to everybody, wherever you are. And thanks to Varun for inviting me to be on the panel. Maybe a 30-second on FAST, Varun, just to explain what we do, right? We are basically a non-profit organization with the mission of strengthening India's science and technology ecosystem to make India a stronger and, in fact, a top three science and technology nation. So with this mission in mind, we work with the triple helix stakeholders, which is the government, institutions, and industry. And we also work with the science and technology youth in the country to drive systematic unlocks in doing research and accelerating the progress. We are actively engaged with various government ministries. We are actively engaged with the institutions across the Indian ecosystem to remove a lot of the roadblocks that comes in the way of doing research. Having said that, and not delving too much into the details on the government engagements that we have, but I can just tell you that India is sitting on a very critical moment here and a defining moment in terms of the efforts going on the science and technology ecosystem. The two big initiatives that Varun talked about, which is the Anusandhan National Research Foundation. ANRF is actually to fund the institutional ecosystem for research in the institutions, and a 50,000 crore fund has been kept aside. This was launched last year, and the fund disbursements are already underway. It's a mission-oriented structure with multiple missions which have been launched over the last year and a half, and we expect this to be ramping up further going forward as we add more capacity in the behind the ANRF efforts. FAST is actively engaged in this effort, supporting the ANRF efforts as well. And then on RDIF, which is the fund for the later stage research, which is for the industry funding, is just very recently been launched in 2025. This is a 1 lakh crore fund where the government is actually going to fund the industry for deep tech research work. So the first fund I talked about, ANRF, was for the government to fund institutions, and this one is for funding the industry. They have come out with an operating mechanism. As I talk, various outreach sessions have been organized by the Department of Science and Technology, and this could be transformational uh, as far as the startup ecosystem is concerned, and with money reaching startups to fund their value of debt situation as well. And we expect that this is going to catalyze the entire industry research ecosystem as well. So, two great initiatives. And besides, I think there is other work going on in the ecosystem where the the government is actually looking at de-risking procurement by having industry and government co-funding in various projects, multiple schemes being launched, right? So there is a lot of positive vibes about the efforts across the ecosystem that's happening today. So I'll just stop it from there. And Varun, if you have any follow-up questions, I'll be happy to answer.
Yeah, absolutely, Sheil. I'm going to come back to you later. Thank you for that. And of course, I would actually recommend pretty much everyone in the audience, including the panelists, to take a look at some of the reports that FAST has put out. Look, reports are just reports, right? But these are actually quite illuminating when it comes to looking at the all of these pathways, what's actually happening in technology translation. We all hear a lot about it. Of course, you on the panel are practitioners, so you get it, right? What the bottlenecks are. But they've created these beautiful reports that help to understand these pathways for India and actually benchmarking against what's best in class globally and how India can play to win, right? Where we should be focusing. So I want to come back to you on that part later. For now, I'm actually going to throw to Dr. Vikram Vishal, who's joining us specially from the Swedish embassy in Mumbai. Is that correct, Dr. Vishal?
Thank you from Delhi, actually, but
Oh, sorry,
never
excuse
mind.
me. So,
Thank
so
you.
I'm just gonna ask you a couple of questions because I know you actually have to drop off because there's an event that you're at right now that's celebrating a launch from yourself. So we'd love to hear a little bit further. So, you're a leader in the area of climate innovation specifically. I mean, specifically in the landscape of CCUS, carbon capture and sequestration, and even steel decarbonization, its applications therein. So we've discussed that the default pathways. So, I'm diving a little bit into the center and then I'm going to zoom out again with some of the other panelists. But, for some of these technologies that you're working on, we've discussed that the default pathways may be not 5 years, but 20 years. So taking some of these examples, what are the barriers and how can we get closer to 5 years from 20 years, right? I mean, if the default is if the default is 20, how do we supercharge that and get closer to 5 years?
So thank you. Thanks, Varun, for inviting me, and it's really a pleasure to be here and listening to the other eminent panelists. Essentially, I'll take the question in a way that, since you've talked about the academia and translating into these technologies, moving to the from lab scale to real ground scale, and as of course how to reduce the timeline for such technology that are new in this space and almost I should say inevitable in the context of climate change particularly. So at IIT Bombay, you can see in the background that I have is DST's National Center of Excellence in CCUS. So first, there is a thought leadership that comes from within the policy of science and technology, which sets up something like this is the first center of excellence in CCUS at IIT Bombay. It was immediately announced after the Prime Minister's announcement for net zero for India for 2070. So definitely there was a lot of impetus that we need to look at pathways for decarbonization. And we realize that in almost all scenarios, we cannot really get rid of the hard to abate sectors without capturing carbon dioxide and converting or storing it into different chemicals. So there was a lot of fundamental support that came from the support from the Department of Science and Technology through this Center of Excellence, which we worked with partners with industries. We got some insights from what they are facing, steel, cement, power, petrochemicals, and so on. And then when we build the technologies, we found that what can move out of this space and go into the industry out there. So as academicians, we look largely at TRL, somewhere between 1 to 3. This is the zone that we're most comfortable with. But then we also, you can see the other logo on my backdrop. It's Urja Novak. That's a clean energy and a net zero solutions company. It's a startup incubated at Sine at IIT Bombay, and it essentially translates the fundamental R&D that was sort of invented and innovated at the DSC's National Center to move out from the laboratories into the market. So currently, for instance, the beaker experiment that we did for carbon capture and conversion, we have now moved from the beaker to essentially TRL 6 plus certifications from companies like BPCL and Forbes Marshall that we received. So the idea is that in a faster timeline, can we have disruptive and innovative technologies which need to go out to the market, essentially because the time is short for climate disruptions. Right. So there are challenges because you asked about the challenges and barriers. There are many challenges. First is that it needs far more investment in R&D and particularly in the startup sector also, like deep tech space, which where we can fail a little more because we are talking about disruptive technologies. So higher amount of funding is required. The generally for setting up the plants, even for TRL 6 and 7, they are high capex and is required, and there's a payback is actually quite long. The second important element is apt policy and regulatory gaps for deployment of such technologies, are also an important thing to look at. The third one is on the overall technology readiness, because many of the academic work is still at TRL3 when we publish and we get the patents out of it. But the value of debt that needs to jump also needs a lot of ecosystem support, and it's not just money I'm talking about. An ecosystem support is required for it to move from there, and trust with the industry is also very, very required. Many of these technologies, the infrastructure that we want to expect has also to be built from scratch, because this was not expected when the industries were set up to how they will retrofit a CCS plant, right? So that's an important element to come to talk about. The risk appetite has to also be corrected. We typically, are averse to some of the risks when it comes to technologies which are at lower TRLs. So that way the risk also has to forward. And the final point which I want to add is the right set of the human capital, I would say, the workforce that is there in the climate tech space or some of the disruptive spaces. It's not enough that is required at this space. So this sector has to collectively evolve and grow. All in all, I see that whether it is the decarbonization sector or generally any of the technologies which are coming up, we need to move a little fast, and that can only happen when we all collaboratively work together. So that partnerships is an important element, and for that I actually congratulate you for doing your bit from your side in bringing the stakeholders together. Thank you.
Thank you so much. I know you have to jump off. Where we are actually just getting started, right? So thank you so much for that praise. I should also state, as Dr. Vishal leaves for his wonderful event that's taking place to announce the achievement, which I'm sure we'll hear more about in coming days. He sits on a lot of these committees that support the government's planning for all of this stuff, as do many of the other panelists here today. So we're certainly keen to work with you more closely, Dr. Vishal, on making that ecosystem more prolific, right? So we've discussed, for example, the steel decarbonization projects that exist. Out of maybe 13 that were funded by the government of India, 8 of those projects have IIT Bombay's name on them, right? And of course, you're front and center in those efforts. But what you said is that, look, if there's 5 labs doing this across India, it's not going to succeed. We're going to be on that 20-year timeline. We need 50 people doing it. So thanks for highlighting that.
Correct. I just take this opportunity to share that you're right. See, the ecosystem is what I'm talking about. IIT Bombay fortunately provides that kind of an ecosystem where a large number of faculty members are invested in taking the technologies out. We have some 70 plus professors who are involved in startups. Our technology business incubator is the oldest in the country in an academic system. We have generated unicorns from IIT Bombay. So, that you can see that our approach from last 25 years, when we moved from teaching and research to teaching, research and translation, and that's the, IITB, I think 3.0 is we can say that we are moving ahead. And finally, as you used in my introduction, that I am also professor in charge for IIT Bombay's Research Park, like, you have other panelists as well. So the Research Park is essentially co-location of the industry on an IIT Bombay campus for joint innovation and translation. So we have a purpose-built 500,000 square feet space available only to the industries to be housed on the IIT Bombay campus. So that is a level of ecosystem support for facilitating interaction with the industries. We believe that in moving the technologies out is quite difficult. So the building this ecosystem is very, very important.
Thank you so much for your time, Dr. Vishal. So on that note, I'm actually going to throw to other panelists now. So speaking of research parks, in the interest of actually in a sort of spirit of competitive cooperation almost, right? So I want to throw to Nat Mallupillai. Thank you so much for joining us, Nat. The IIT Research Park at IIT Madras has actually been a fantastic lighthouse model for some of the things that Dr. Vishal described, right? So translating the research heft of the university into ventures and spin-outs. Could you speak to the overall model of the research park and what would you say are the ingredients that have gone into making it such a success?
Sure. Thank you. And again, thanks for doing this. I think, and fantastic overview as well. I think as I come into the discussion, I was thinking, what do I talk about? But I think we can talk enough about the things, slides that you had in terms of climate being a problem and needing a solution. But I'm going to try and stick to my lane about the research park and translational research, but maybe quickly jump into the other aspects as well. So yeah, I think research park incubation cell, I think it's an ecosystem, right? And I think we have about 1.2 million square feet for industries and startups to come and collaborate. And I think what makes this beautiful is, again, similar to what Dr. Vishal talked about as well. The extent of participation from the IITM faculty and the PhDs and postdocs and interns and all of them, I think roughly about 40% of the faculty actually participate in some of these initiatives. Several of them go on to be co-founders. To me, I think that's a brilliant initiative from IIT Madras to incentivize faculty to go beyond teaching and publishing to say, stretch your entrepreneurial muscle as well, much like you and your students are doing a thesis and project. Now it's time to take it one step ahead, translation, commercialization, and do startups. And that's really encouraged and actually incentivized. I think that's what makes IIT Madras Research Park stand apart. And when I say stand apart, I think all of us do really well. I mean, IIT Bombay, IM Ventures, and all of that. But I think that we all need to do this together, right? It is about the different aspects of technology that we need to unlock. And I would love for us to even collaborate more, right? It's not, we have brilliant people across, and to be able to tap into each of those trends and do that is what's most important as we think about challenges like net zero. So I think that's one. And I think the beauty of the ecosystem is different industries come in to set up the R&D centers here. In many cases, IIT Madras Research Park is the premier design center for the companies over here, like a Saint Gobain, for example, or a Pfizer or a Caterpillar. Everybody comes here, cross-functional team, both within their centers and within the IITM departments as well. I think that makes it, a customer-facing problem. It's not a department problem. It is not a subject matter problem, but it's really use case driven. How do we need to bring every expert together to solve problems? So that kind of what makes all of the research parks in incubation cell of sorts to work well. So that's the second part of it. And as we think about the other founding factors, it's also about enabling capital to be available for the research. We talk about grants at early stage, but also getting into some kind of equity. We have venture capitalists sitting amongst us, and as most of us are doing, we are starting our own venture capital fund as well to solve some of these tough problems. And our own thesis is we need the founders to really focus on perfecting their product, really making sure the product market fit is there, the unit economics is there. I think early stages, at least some of the tech founders we see spend inordinate amount of time going after funding. And I think there is it's a long wait time game. And so one of the ways we are trying to tackle it is, since we know them really well, coming from our pre-incubators within the campus, coming to incubation, spending about 3-4 years, we have a ringside view into the founders, their persistence, their hustle, and how convinced they are about the solution. So I think we are willing to take a deeper bet in terms of funding them. So that's the funding problem is taken care. The second aspect is the human capital that I think was also talked about. How do we generate more human capital for some of these sunrise sectors? We're talking about EV, we're talking about charging infrastructure, we're talking about semiconductor, within IIT Madras Research Park, lab-grown diamonds. I think one of the things that stunts their growth in terms of scaling up is not having adequate human resources for various aspects of it, to be able to set up a factory floor, to be able to maintain it, to be able to provide servicing to it from different parts of supply chain. I think we kind of think step by step as opposed to thinking ecosystem. So those are some of the things we are collectively tackling within the research park ecosystem as well, saying that here is a center of excellence where you have fundamental research happening in the campus, but once it comes out, we're going to have industry, or government and industry say we're going to fund it 60-70% of it, and we'll take the fundamental research you've done, spend another 3-4 years of doing translational research, and go to kind of go to marketplace. And with the industry is also being co-located with the center of excellence, that the dialogue becomes very active, right? So saying, well, yeah, you're doing this, but in my market, in my sector, these are the problems in which we need to retrofit or do it differently. So that conversation is very, very real and interactive. That makes the time to market that much faster, because you're not going to the market and having to test and come back. You're doing it in the lab where you have all these participants sitting very in close proximity to. So I think that's one interesting thing why this it makes it work. And the last thing I'm going to talk about is the financing model itself. I talked about the venture capital, but also the blended financing that happens for all these things. Climate specifically is very, very capital intensive, right? I mean, it's a high capital intensity sector, and the wait time is also a lot. I mean, for it to bear results. And typically, the buyers are not necessarily a B2C kind of models. It could be the government or large industry players, and they have to also balance between their short-term profits and long-term bets that they make. And these are all behavioral changes that the entire actors need to make, and that's why government participation, the whole ANRF and RDA that we spoke about, is extremely important to be able to fund, including the focused research organization which came as part of RDIF. That's extremely important to make long-term bets, build infrastructure, build working spaces, lab facilities that's shared by all. That's kind of what this entire research park ecosystem work, and we think this is going to be extremely important if you have to solve tough to abate problems, specifically like climate sector. So I'm going to stop there and I'll come back for more.
Noted. Yeah, thank you so much for sharing all of that. I'm going to jump quickly to Dr. Abdul Rab. So I mentioned, ITRI is a very interesting mission-focused organization. I would say similar to FAST as well. Could you tell us more about kind of the conceptual opportunities you have identified to address these valleys of death that people have referenced in translational research, and kind of how you are laser focused and building these extensive programs to close these gaps, with perhaps with an example of a climate relevant case that you're already working on? You'll have to unmute yourself. Sorry, Dr. Rab.
Apologies. Thanks, Varun. Thanks for the invitation. Happy to be here. ITRI stands for India's Translational Research Initiative, and the genesis of it was the recognition. I think this is something that is widely appreciated. There is a value of death, so to speak, in technology. TRL 4 to 7. Professor publishes a paper, TRL 3 to 4. Things kind of stop there because the novelty of the concept is exhausted. Now, whether I have demonstrated a catalyst for 5 hours or 500 hours, it doesn't change the number of papers I get out of it. And there needs to be a very strong pull from the industry to take it to the other side, which is TRL 8 to 9. Innovation is a very complex system, and you could pull multiple levers to perfect it or improve the efficiency of it. And organizations like yourself are taking a very systemic view, intervening at the policy, stakeholder level, and so on. And so is ANRF, RDIF. FAST takes a different approach, a very policy-centric approach towards how to improve the efficiency of this particular system. So the ITRI way of looking at translation is, in my view, a bit unique. So the TRL 4 to 7 gap is there. Technology stalls at TRL 3 to 4. What do you need to take it to the next level? You need infrastructure, you need people, you need policies, and so on. But the other, I think, key aspect of how IT looks at it is many of the discussions across the board when it comes to translation are systemic, meaning like, solve climate, solve agri, solve food, and so on. But these solutions are dependent on components that are one to many. For instance, you asked me about climate specific. For instance, membranes are used in climate. Membranes are used in monoclonal antibodies in biologics. They are used in desalination. They are used in decarbonization, multiple. But there are many faculties that are working on membranes. So they could produce in their labs a 10-centimeter membrane that's good enough to publish a paper. But if I go to a startup or an industry, they cannot work with a 10 centimeter membrane. Even at the pilot or pre-pilot, they need something in meter scale. Who's going to produce this? There is no private industry producing, three pieces of, 2 meter square membrane. So a lot of these technologies actually fall through the cracks right here because neither the startups nor industries can actually access these technologies that are coming from academia. The view of ITRI is that if we could create common national facilities for membranes, for ceramics, for magnets, for a variety of what we consider foundational technology that touch many industries, right? Biologics industries, chemical industries, and so on. This will become a valuable common asset that is accessible to startups, that is accessible to industries and academia. For instance, if I were to produce a translational 4 to 7 facility for membrane, every university doesn't need it. I mean, you just need maybe 5 facilities across the country, right? That's the idea. The idea is to create at the component level. The other point that I would like to make strongly, and whenever I get an opportunity, I make this is if you look at major industries in India, the software industry, the pharma industry, and now the biologics industry that is growing the modus operandi is to sort of import the tools and run solutions and offer services and to mostly demand centers that are outside of India, both for pharma as well as software. This is true, and this is kind of emerging as true for biologics industry as well. So my impression is that unless we become tool makers, like for instance, we develop our own ultrasound systems or our own gene editing systems and so on, there will always be that dependency. And that's something that you see sector after sector when it comes to components. For instance, more than 90% of the sensors, you talked about climate systems, more than 90% of the sensors come from outside across the board, not just for climate. So at the component level, what we really say make in India is import in India, right? So the emphasis is not there to create the components and also to the tools, for instance, XRD systems or a variety of other systems that are used that are the foundations of science are also imported. So that equation needs to change. Our goal and our vision is that can we intervene at that critical gap at the component level, not at the system level. I think there is enough and more funding and other things happening at the system level, but the view at the component level is sparse, and we would like to play a role in filling that gap. So I'll stop there, Varun.
I mean, honestly, a very fascinating perspective and really interesting, really highly leveraged view on kind of focusing on a very specific thing, which is nonetheless a massive challenge. Not trying to minimize the nature of the challenge, of course, but it could be a really high leverage intervention, right? Setting up these centers of excellence. You said membranes, one-to-many approaches. I should also mention Dr. Ab has extensive background in private industry as well as subsequently at IIT Bombay before joining as CEO of ITRI. So really interesting perspective. Thank you for sharing that. Dr. Namita Gupta, thank you so much for joining us. So just wanted to say, IIT Delhi, we've heard from IIT Bombay and IIT Madras. IIT Delhi also has kind of fantastic research groups in areas of relevance for climate, such as, we've talked about the LC3 Cement Research Group. What is FITT's role in the university ecosystem and what has worked well for you thus far? So could you identify some gaps or opportunities to strengthen these kind of
Absolutely.
translations?
Right. Thank you so much, Varun. And first of all, apologies for joining in so late. Some tech issue I really could not figure out. Even though we are like this tech-driven organization, I could not figure out the tech issue. So yeah, so FITT basically is the interface organization for IIT Delhi. So interface between the lab and the market. And how we are acting as the interface is that our role spans the entire ecosystem, right from IP creation to IP protection to IP commercialization. So we act with industries as a co-development partner. So we act as the facilitation body for R&D projects, for consultancy projects, wherein the industries would come to us with their problems, and then we try and get the right solutions from the labs at IIT Delhi. So we try and do the matchmaking with the industries, the industry problem, and identify the right expertise at IIT Delhi. So this is wherein we help in the IP creation part. Then, of course, we are the IP management arm of IIT Delhi. So we help in the protection of these IPs through the filings of patents, copyrights, trademarks, whatsoever. So we have a whole team of patent agents and trademark agents, and we, do this the IP protection part. Now comes the most important part is that what do we do with this IP which has been generated and how do we bring it to the market? So the commercialization part. So herein, again, so the ones that we co-develop with industries, those are directly given to those industries for commercialization. Then the ones that are developed using, say, some government funds. So we act as the technology transfer organization, wherein we try and give out these inventions to industries of interest. So we'll try and find the right partner organizations who can then take it up by via licensing agreement. And the third, of course, and the currently the most important one is through spin-off formations. So these could be faculty-led spin-offs, these can be student-led spin-offs. So essentially, this is what we do and how we facilitate. And we are also we also take care of the R&I park of IIT Delhi, where in the same model as IIT Madras, we have these corporate spaces for companies who set up their small R&D units, wherein they can then directly interact with the faculty members, with the students, with the startups which are stationed at our incubation center. So we have some good names in the R&I park currently. We have TCS, we have Novo Nordisk, we have Mitsui. We're in conversation with companies, some other companies, to set up their R&D centers, which becomes a sort of a win-win situation wherein the industry can give their exact perspective as to what the actual industry need is, and we can then provide the solutions via our labs or via the startups that we have in here. So just as an example, we try and support our faculty spin-offs by initiating funds. Like we have initiated a faculty-led startup spin-off creation fund, which is a fit fund. So we do this whole exercise wherein we had an application process. The faculties came up with their proposals, and then we are inducting those startups within our incubation center. So essentially, these are the ways. This is what the role broadly of fit is. And of course, the problem areas is the same as when we do research at the lab level. It would be a TRL 3, TRL 4, but what industry is wanting a TRL 7 plus. So that gap is there. How do we try and bridge that gap? So we're trying various things. In some ways, we try and do those joint proposals with industry through the government schemes, like the DST schemes are there. So we try and bring a industry partner on board to apply for those schemes. We are trying and raising some CSR funds, wherein those funds can then be used for that gap, for overcoming that gap of that TRL 4 to TRL 7, because those CSR funds from our industry partners, from our alumni associations, we're trying to generate those CSR funds. Then a big another way that I would say is wherein, as I said, that the co-development that we're already doing, that is a big way actually of working on the exact industry problem. So that I think is one of the most successful models, is wherein the industry can come up right from the beginning, and we can work together to bring the solution to the market. So yeah, essentially this is what our entire portfolio is around.
Fantastic. And seeing some degree of convergence across the different models at the different IITs. And of course, you guys are the engine of, you guys and gals are the engine of innovation in the country, alongside many of the other universities that exist as well. I should also mention there are other fantastic ecosystem builders, not just us, we're just getting started, but fantastic ecosystem builders that are doing work at BITS Pilani and etc. Sus Mafia, some of you are in the audience. So thank you so much to everyone for your work. I should also state that, among the panelists, we should interact and kind of see how we can cooperate and take things forward. And crucially, people in the audience, please reach out to these folks, right? I mean, a lot of what they're detailing is opportunities to engage and kind of move forward. I think, just taking a step back, one broader reflection is that India seems to have a special set of opportunities and challenges to move forward and think about how do we play to win, right? So I want to go back to you, Sheel, in terms of, you guys did a lot of thinking around, where should we actually focus our attention if we have to make India a top 2, 3 science and tech nation, which we should be, right? By the way, as a backdrop, there's people on this call who are from outside India as well. While the panelists' scope is focused on India, a lot of these challenges actually generalize really well to some of the other developing world contexts, right? So I just wanted to state that. But Sheel, specific to India, kind of what have you folks thought about as India's opportunity to play to win? You're on mute.
Okay. Yeah. So Varun, I think that's a great question. I think India has an opportunity, which is to be kind of a natural bridge between the advanced countries and the developing countries. Especially, we have an opportunity to be a leader in the global south, right? In terms of bringing technology solutions whether it is in the area of sustainability, sustainable agriculture, whether it could be renewable energy, clean cooking, green hydrogen. There are various niches where India can really play a role on technologies as well. But I think more importantly, I think we were discussing in the beginning some of the challenges as we do that. It is to address some of the basic challenges that we have today. So, for example, I think there is a role that the government would need to play in order to ensure that there is better ease of doing research, right? Our scientists find it easier to do research. So, FAST did a study some time back which showed that the fund disbursement to the institutions where research is done, right, it takes a lot more time. And the disbursement of those funds needs to be faster, and the processes need to be a lot more convenient for our researchers. We also got to take a lot more risks, which is something that if you look at our risk-taking ability, I think there's a natural tendency to be in a zone of comfort. So researchers would need to be given challenging, grand challenges, may you call it. It's the best example that I have is the Fuji Kodak example, where they had analog cameras being built until they moved towards digital cameras, and it was disruptive, right? So disruptive technologies will come through more increased risk taking, and that's something we have to encourage across the ecosystem. And I think you will find that there are pockets where that is already happening. We need to scale that up across our institutional ecosystem. There is a lot of work that still needs to be done for the government to actually play some more leadership role in procurement, right? De-risking a lot of the risk associated with the market risks, right? So that's where I think we have been talking about demand aggregation and procurement guarantees by the government. With that, the risk around innovation, which is naturally there is a natural risk around any kind of innovation efforts, that will get reduced as well. So a few of these levers need to be addressed, but the technologies that we are talking about on sustainable agriculture, it could be on solar cells. And we've seen some great examples in IIT Bombay where they have perovskite cells with a 30% plus efficiency level, conversion efficiency level being actually made in the labs, and now they're looking at scaling it up. So we'll have to figure out how do we get risk capital, patient capital in place, address these issues related to ease of doing research, get the market side risks to be covered, and really try and scale this up going forward. One other comment on research translation. I think some of the other panelists talked about research translation. We have to get into this mindset of getting into commercialization and translation of the research. It has to be beyond, it has to be basic research at the institution, but it also has to be how do we bring that products to the market and commercialize it. And a whole effort around that, as you can see today, a lot of the industry is beginning to talk about commercialization of research and really connecting with the institutional ecosystem. So a lot more effort needs to happen in that track as well. But great opportunities for India. The good news is discussions like these are happening a lot more. I see them almost happening every week now, which is a good sign. And I think we should start seeing some impact going forward.
Yeah, fantastic. Thank you so much for that, Sheel. Dr. Rab, I just wanted to follow up with you. So, I mean, some of the additional reflections are that, China has taken things forward very systematically over the last 25 years in several strategic industries. As Sheel mentioned, we have a special place in the world, which might be sitting at the in between what's known as the developed world and the developing world, being at the vanguard of like this surging global south, right? If you had to identify, barriers that mean we don't succeed and we don't get to the level we need to get to in terms of punching at our weight over the next 10, 20, 50 years, like could you do a pre-mortem of that? Why would you say we will not succeed?
So, Varun, I think it will come down to the risk taking, something that Sheel touched upon, right? So there is basic foundational research, technologies that change the world forever, internet, transistor, and so on. Those are massive, massive value creators, gene editing, for instance. And then there is a translational piece. Okay, somebody has shown the proof of concept. Now I need to extract value from that concept. my view is that given what I've seen with AI, where it's going, even ANRF's own AI for science and engineering, that translational piece, which is moving the TRL level, will largely be reduced to AI. So, because, at the end of the day, what happens if you do it as an individual is you generate a series of rational hypotheses and you need to have a way to, be able to test these hypotheses. And that's a step trial and error process. With AI, you will be able to significantly smash the times required for hypothesis generation. And also with massively parallel high throughput experimentation, you will be able to, drug discovery is going this way. You know this. Now, this is a good and a bad news because at the global level, a lot of the solution that you're looking for to solve climate will be done much faster than what used to happen with, completely human enabled way of doing things. But where does India stand? What the layer of value that we will capture so that the socioeconomic impact can be driven for the country? Now, that's a nuanced question. Right? Where should we play? It's a complex game. Largely, the answer that I hear in the panels that we should do everything all at once, right? That is, I don't take that view. I think if you only have $10 to invest, I don't think we should split that into $1 and invest equally everywhere. There are some strategic bets that we need to take. So from my perspective, the strategic opportunities for India is biotech, climate, and agri. I mean, even today, 50% of the workforce is in agri. It's a traditional agri country. I think what makes it special is people from two perspectives. If you look at global ecosystems, whether it's Singapore or the US, the intellectual capital in a lot of this ecosystems comes from India. So that's there, the base is there. Second is that, above and beyond that, the biological diversity, the genetic diversity and ecological diversity that this country harbors. For instance, you could see a desert, you could see seashores, you could see temperature, it's a living lab, right? So, for instance, you could find a lot of different isolated biological conditions. They call it human knockouts. You can find that in Indian populations. Ecological niches as well. Like, for instance, everybody knows now what is known as PCR, polymerase chain reaction, which was enabled by a discovery of an extremophile, a particular enzyme that was found in a bacteria at a certain temperature. Now, how many such niches do you have in India? A lot. Who's doing that discovery? Not. So we need to go deeper in the value chain. I don't think we could play the superficial game of 5-10% margin extractions. We really need to take bets. Some of them are going to fail. Many of them are going to fail. Some of them are going to succeed, and those some will more than make up for the ones that fail. I think we should. I second Shield's view on that. So what the faculty needs, faculty, today go from grant to grant, right? Sometimes you talk to them, they don't even know, for instance, when the next grant is going to be. How do you expect someone like that to take next bets, right? So we should do 5 to 7 year deep horizon, no questions asked, go do your research. But the question asked should be that of quality. Where are you publishing? Are you publishing in Science and Nature, a top 1%? So, India is the third largest publisher in terms of publications, but our contribution to the top 1% cited is less than 5%. What does it tell you about the quality factor of these publications, right? So they just focus on quality factors, fund deep. That's what US did, come to think of it, over several decades. So today we look at the US and say, it's a great example of innovation, but didn't happen overnight, didn't happen in 10 years. For a very, very long time, that country has had a position of just open-ended research, curiosity-driven science. I mean, I keep giving the example of something that has changed our lives and life on Earth forever going forward is the discovery of gene editing. And that was completely curiosity driven. Scientists were merely curious about how bacteria and viruses interact, and that changed everything. I think, that's the strength of India. I think that's where we should focus. In the short term, that is going to require lots of investment and, maybe nothing for the next. I don't think it's going to be nothing. I think things have changed a lot, but we need to take that leap of faith and be able to say, here's 50,000 crores, go do the greatest science, bring us some Nobel Prizes. I think that's my view.
Yeah, fantastic and inspiring words, actually. Thank you so much for that. I have some reflections. I'm going to keep them to myself because we're already running a little bit over time. I want to throw to Nat again. Just pulling a little bit out of what Dr. Rub said as well there. Of course, you need the basic science and the messing around aspect of science, the tinkering aspect of science to get to some of these mega inventions and innovations. Could we zoom in a little bit more about kind of industry linkages, real world applications though? Because I guess the question is, what is inhibiting those from happening with greater velocity? This is something that we've all discussed, right? These IIT Madras Research Park, as you said, has a lot of these structures that have been developed. Is it simply that these are now coming to a head and coming to fruition, or what is inhibiting this from happening with much greater prolificity and velocity?
Yeah, I think the broader macro answer has always been, I think we've been through this challenge for quite a number of years, and including our R&D spend being a meager percent compared to how the developed countries do, right? I mean, and we kind of fight that to say, what could we do? How could private sector step in and put more money to spur R&D and so on? And some of it is also a bit of the easy money available to do easy things and make money, right? The slight manufacturing tweaks, the reduce the cost of manufacturing, things like that, which I think industry will always go down the path of least resistance to make money quarter by quarter. I think that's world over that happens. But I think the broader challenge is to have greater imagination to say, if I want to build a empire, build a legacy in terms of making technology affordable, making dignity of life or access to whatever it is that people need access to, how am I going to make that bet? So I think that's the reimagination that I see happening over the last 5, 10 years, right? In different forms. So we're beginning to make bold bets. There are infrastructure that's being laid out. I think the whole we talk about this whole digital public infrastructure being a role model as to what is possible if we did that right, and then everybody, private sector innovation comes on top of it and flatlines access for other people. So I think that's the kind of thing now it's beginning to happen in, be it space, be it drones, be it defense. I mean, I would throw in some of those sectors in addition to what Rob said. So I think it's very important to also look at the frontier sectors from, you know, defense, if you will, and how do we protect our interests and so on. I think the last 3, 4 years has been a testament as to what is possible if we channelize investments in this space. And I think there are a couple of other points that I would agree with, saying we do not want stunted investments, and that's something that we see here. They all get stuck at a pre-series A. I mean, talking venture capital and startups. So how do we double down, triple down? Much to the point about 7, 8 years of investment not being a bottleneck for them. And similarly, industry is kind of chiming in to be a co-partner in their development and giving them the first order, the second order, knowing there might be quality issues and so on. I think these are behavioral issues that I'm talking to the industry about. We need to be partners in it, not treat them as supplier, customer in every sense of the way, but really in a partner as a co-development. So when I think about research ecosystem here, that are the kind of messages that we're driving with the industry being here, the startups being here. How could industry take an active interest in startups being part of their solution supply chain? How could they help them become better? How should they help them think global? A lot of startups don't think global day one. They can't afford to. They are bootstrapped. So how do we, if you want to build in India but build for the world, how do you comply with their certification needs and the material specs and certifications and data privacy, things like that, rather than that being an afterthought which stops investments from coming in. So those are some of the shifts that are happening. It's all driven by a few success stories. I'm a firm believer, the whole Aether IPO for us or Agnicool for us, that creates several more copycats in a good way who all are kind of following how this is a template for us to now build a solution, build an ecosystem. So that's happening. And the one last point I want to end with is we also have to imagine in a much more bolder way. We can't just look for point solutions. I mean, in many cases, we'll have to be vertically integrated. We have to think full stack. It's about, I have a power charger company here that's doing fantastic work to be fully indigenous, but the power controls or the electronics is still not indigenized. So I think that's again where this ecosystem approach saying, who can now step in and to produce that, make India produce enough of those, and should the policies somehow support it? Should we subsidize them in the early stages to make it to make the technology accessible to them? So I think this is where it's everybody. It's not just any one magic bullet. While the entrepreneurs need to come in and innovate, and the experts and research scientists need to contribute towards it, it's also the funding, it's also the policy to make all of this possible. And that's kind of what we aspire for in research park ecosystems such as ours and several others in the country as well.
Thank you so much. And we're running a little bit late, so I want to close out with this final question. You mentioned that it's really all indexed on successes and case studies, right? So I mean, not all indexed, but they certainly help to build the imagination and then coalesce a number of resources behind these institutions. So just putting a question out to the entire panel, Does anyone want to highlight, this is panel one, does anyone want to highlight any case studies of success that you are looking to emulate or that you are taking inspiration from that are developing world or India specific? You've already mentioned a couple, of course, relating to your specific universities.
I think I'll go first, but I've always been impressed with what IIT Madras Research Park has done, right? Aether technologies in terms of, Nat talked about Aether, but the story of Aether in terms of how a startup has actually benefited from the research ecosystem, the research park, and then actually scaled it up as well. And the key thing there has been the focus that the team there has had. They've had a conviction on using EV, right? Having a EV scooter and then scaling up the solution, and then continuously investing in innovation, right? If I'm not mistaken, their R&D intensity is north of 20%. When I say R&D intensity for everybody, it is the expenses on R&D cost as a percentage of the revenue. So 20% of the revenue is actually R&D cost. And if an organization spends that much, clearly there's going to be new innovation and new products which they will come out with, and they'll see the benefits of that. So I've been impressed by the focus that they've had and the way they've driven it across the system.
I'll add one more to that. I mean, we have company, I'm sure across the board, we have another company that's trying to invent a heart pump, right? And this is again very, very impressed with some of these med tech and health tech kind of inventions where you're really imagining how can you reduce the cost of these things for the common person. I mean, currently the only global model available is a Johnson and Johnson system that costs you north of 80 lakhs for a treatment, and the team of doctors and startup enthusiasts working together to reduce the cost to about 2-3 lakhs, right? Using titanium and using very high class engineering design type challenges to cut the cost down. And this again will bring in several other innovations in the space. I mean, as that goes through it, I'm already beginning to see teams. I mean, that's been a thing, right? Like Flipkart was very successful. You have several teams coming on Flipkart. We had the Zoho here, which is software as a service, several people coming off it. I'm beginning to see similarly, from IITM ecosystem, an Agnikul came and Galaxy came and Hyperloop came. So those are the kind of flywheels that emanate from a few success stories. And we have already seen enough of them.
Fantastic. Abdur, you had something to add?
Just very quickly, I think the example that to me comes to mind is healthcare innovation is very hard. You need to jump through many hoops to actually get it to. And many times the discussion in the ecosystems is we must have a medical school. We should have co-located with a medical school. So the example that comes to mind is ImmunoAct from IIT Bombay. CAR T for cancer is a very new therapy, even in the US, costed almost $500,000. So Professor Rahul said about with the vision of making it accessible in India with a very short span of 6 to 7 years, based out of an engineering school, got it commercial, got it approved through CDSCO, and now his therapy is available all over the country. His was the first company to be able to commercialize it. Now I'm told that there are more than 40 plus companies working in the area of CAR T and other cellular therapy, cell and gene therapies for a variety of different conditions. I'm a big believer that India can be a delivery destination of healthcare globally for discovery as well as therapies and so on. So that's something that I'm proud of.
Very nice, and definitely something we're looking to benchmark against for climate. By the way, you got stuck, but in a typically erudite pose. So we heard everything you said, though. Dr. Gupta, you wanted to add something there?
So, what I'd like to say, echo is one of the co-panelists say, that if we have some sort of the startups have that uh, cushion of that, there'll be some orders, and also this we can say especially from our defense portfolio that we have. So we have quite a big cohort of defense startups wherein they are getting funding directly from the army or the forces, and with orders built in, that if they reach these milestones, then they get those orders, and they are seeing a lot of success because of that. So that cushioning of revenues is really making a lot of difference in then able to work on the ideas, then able to deliver on those ideas. So I think that is something very important, that from somewhere we are able to give that you know, that to the startup that they will be able to get something out of it, so that all their effort is not going to waste. If we are able to give them that sort of, I'm not getting the right word, but that thought that yes, they'll be getting something in return. So I think, especially for the defense one, we've seen a lot of success
Yeah,
in that
incentive
portfolio.
structures, etc. That makes sense for everyone's kind of mutual gain. Makes a lot of
Yeah.
sense. Thank you so much. We're a little bit over time here, but so I'm going to say thank you so much to all of our panelists for panel one, Sheel, Dr. Abdul Rab, Dr. Namita Gupta, Nat, and of course, Dr. Vikram Vishal, who had to leave earlier. Thank you so much for your time. Really appreciate it. We'd love if you stick around as well for the second panel. By the way, a little bit of context on the second panel. You'll notice if you're in the audience, in fact, many of you are probably here because you recognize this. There's something deeply exciting about climate tech ventures or the venture world in general. Many of the case studies of success and inspiration that the panel one highlighted were in fact ventures, right? So that's something that I think captures the imagination, and rightly so, right? Oftentimes it's the ability to scale these innovations and kind of bring them to the widest group of people. And the venture can be a fantastic model for that. We have a great panel to address that, including a great moderator, Mridu Jhangiani. Thank you so much for joining us. I'll just do a quick introduction and then throw to you, Mridu. We have Dr. Satya Sheshadri, who's the head of the School of Innovation and Entrepreneurship at IIT Madras, among many other things, by the way, and he'll talk about those things. He's also a co-founder at Indus DC, which is a venture builder focused specifically on decarbonization ventures, so very relevant here. We have Bharti Singla, who's a principal at Momentum Capital and has a fantastic entrepreneurial background herself of scaling a deep tech venture called Chakra Innovations. And Momentum Capital is a very interesting funding organization, a VC fund that does international kind of India to the world type startups. We have Rahul Seth, who's the founder and general partner at Industrial 47, which funds and intervenes at extremely early stages of frontier ventures. So really exciting, companies, including some of the questions are about nuclear, etc. He's got some of those in his portfolio. We have Maya Chandrasekharan, who's the co-founder and partner at Green Artha, also a very interesting organization that takes on different types of financing structures for different stages of companies, especially in the climate landscape. And then we have Nidhi Mathur, who's a venture partner at Axelor Labs and also has a lot of previous in starting and scaling deep tech ventures. And finally, our moderator, Mridu Jhangiani, who's the founder of Terrarium. Again, a very interesting ecosystem building style organization, which we take a lot of inspiration from. So Mridu, would love for you to talk a little bit about your work at Terrarium, which is kind of an insights engine for materials innovation. Materials innovation, of course, being a lens that cuts across many, many things, including climate innovation. I'll stop sharing here and just throw to you, Mridu, to tell us a little bit in a couple of minutes about your work and the learnings there, and then throw to you to moderate this second panel. Thank you so much.
Thanks, Varun. Thanks so much for having me. And I did join a little early, so I did also get the chance to be a part of the panel before, and it was super exciting. And I'm very glad to be a part of this. In the interest of time, I'll just give you a brief overview of what we do at Terrarium. And I know a lot of the questions that we dive into later in this panel kind of touch upon, the challenges and enablers. And so, long story short, we do define Terrarium as an insight engine and a collaboration platform that's dedicated to early stage founders that are building next generation materials. And when I say next generation materials, I'm talking about materials that are better on the sustainability aspect, but also in terms of performance. And I think we've realized that because this ecosystem is still maturing and we're dealing with a lot of first of its kind technologies, products, there is no traditional playbook. And so we think it's really important that for the founders that are in the early stages, there needs to be a way to bridge the information gap, right? There needs to be a way in which we can help founders make better decisions, forge the right kind of strategic partnerships, and just create a space where the learning can happen between founders, but there's also access to industry mentors who have seen sort of things scale from sort of bench scale to industrial scale over their years of 30, 40 years of experience in the industry. And lastly, I think like one really important metric of success for us is beyond information sharing, how many of these conversations or connections or forums lead to actual collaborations between startups, between industries and mentors. Or, I mean, the best case is, of course, if a startup can actually find an early customer for their product. And so really, in a sense, like the model is a very community-led, like diagnostic case clinic kind of format. In practice, what this looks like is us partnering with strategic partners who could be VCs, nonprofits, corporates who have some incentive to be doing this with us, right? They could have been an early investor in a certain technology, or say with TDK Ventures, batteries just was a natural fit. And so what we do like in each session is we bring early stage founders together physically in a space, and we try to keep the session very focused on a specific sector and a specific challenge within that. So founders, talk about their experiences, how they have navigated these challenges, what are current roadblocks, and the rest of the community sort of leans in and shares information from their own experiences. And then we layer that on by basically enabling access to industry mentors. So, for example, when we talk about storytelling and marketing in biotech, we had the former creative director of Ginkgo Bioworks come and do a 1.5 hour workshop. When we spoke about regulation and certificates, we had someone from TUV come in and talk about like the fragmentation and how they're seeing the space evolve, especially for startups who want to go global. And so I think that's like, the long story short of what this looks like in both like vision as well as in execution. And I know you had a question also around like what are some of the challenges that have come up, and what are some of the enablers that we've seen. I think the challenges in many ways are sort of common to what we see across the deep tech ecosystem. A lot of founders, even in the material space, do talk about like the lack of patient capital, talent being a problem, getting their first pilots, converting them to purchase orders, weakly enforced regulation, lack of policy around certain things, cost competitiveness. I think the sort of challenges remain the same. But I think in terms of like what I've seen as an enabler and what I've seen to be interesting, I think irrespective of whether we're doing a session on like low carbon building materials or we're doing something else on, battery tech, a few things that have like often come up in a recurring pattern is the importance of like teams, both from the investors who come on some of these, AMA platforms, or industry mentors or founders themselves, when they reflect on what's been helpful. And I think that first piece of just even if you're a solo entrepreneur, if you're able to like build the right founding team, get the right active advisors on your board, the question of like pushing for another co-founder, it's not about just having another co-founder. It's like what value do they bring? It's not for the sake of having one, right? So we've heard interesting stories about how investors are also not kind of pushing as long as they find confidence in the team that you've built. So I think just early teams, founding teams has been one thing that's always stood out irrespective of the session we've done. I think the second thing that I've personally noticed is like the importance of storytelling, especially like when we're talking about deep tech. And this might sound really simple, but I think the ability to like articulate a clear problem statement, talk about your vision, and at the same time talk about the technology and the science without completely diluting it is a skill that I think is very, very important, but it's hard to find and it takes some nurturing and intention. But I think that can really help like startups go a long way, especially in the early days when there's a lot to prove. And I think the third thing that has come up constantly is like, how do you, have this take a stepping stone approach in your strategy, but still have a long-term vision, right? And what I like the small, like, is it your small milestones that you said? Is it like, how do you build that track record that basically the question of risk that comes up, how do you sort of mitigate that with smaller proof points? And so a lot of the conversation has been about that persistence, about de-risking tech with small milestones, hitting internal milestones, smaller partnerships. It doesn't have to be a large corporate partnership on day one that you're trying to crack, but what else can you do to build proof of demand? So I think that's like largely like what we've seen across themes, and it's just more cross-cutting. But I'll take a pause there. I know I've said a lot of things, and I would love to switch over.
Hand over to you for lead, Mridu, for the moderation. We have about 40 minutes just as a heads up in case, some panelists might have a hard stop. And thank you everyone for your patience. Of course, we had some technical issues as should be expected, I'm sure. Okay, thank you so much.
Yeah, okay. Switching over to moderator mode then. So I think we've got a couple of perspectives and, a breadth of panelists, research, venture building, investing, and I'm also seeing a lot of familiar faces, so that's really nice to reconnect. But let's start with Dr. Satya. Dr. Satya, you have a prolific history of research and applications in industrial heat and energy efficiency, as well as entrepreneurship. And you recently also co-founded IndusDC. And we'd be curious to understand from your, expertise across these spaces, what have you identified as gaps in the ecosystem at the early stage and industrial scale? And lastly, why did you choose to co-found IndusDC to address some of these?
Sure. Thank you, Mridu. Nice meeting you all. It's a pleasure to be here. Just a quick background. I'm a faculty in IIT Madras, not IIT Madras Research Park. So I do head the energy systems program at IIT, and I've been working in this space for the last 17 years. So the journey itself started in the industry, where I was working on technology deployments and with a specific focus on in India for India projects at GE. Switched over to Forbes Marshall to have a greater ground connect, because in India for a multinational doesn't translate very well to the ground. So switched to Forbes Marshall for a ground connect. And also that's the time I moved to Research Park to set up their R&D center, exploratory R&D center. But soon realized there is a huge gap between what technology is needed and what's getting translated. That's when I made the switch to academia about 10 years back to set up the focus group on energy. Lab was called the Energy and Emissions Research Group, with the primary intention that I want to address the technology gaps that are found in the industry that could be translated from labs. So in that process, there were a couple of critical challenges and also opportunities. So back in 2015 is where most institutions in India started taking translation a lot more seriously, which means there are not many professors or faculty with experience of translating stuff from a tiny laboratory, which would give them all they want at that point in their career. Papers, patents, students, everything is done. So there's no real need for translation. And there is also not much recognition for translation from a pure academic perspective. So that was where you could obviously see there is lots of money invested by DST, DBT, MIT, all of those agencies in the hardcore research institutions in India. And always this complaint that nothing is coming out. And you couldn't blame the faculty also because there is no example. There are a few examples, but not much that could be replicated. I think that started changing. And now you can see a lot more faculty attempting to do this and not particularly being bound only by the traditional metrics of academic research. Now you can see a Satya Chakravarti who's aiming for Agnikul, Cosmos, E-Plane Company, Tutor, Hyperloop. So this is another thing that we are currently also seeing, that in a research lab, there is obviously many technologies being worked on. And once you start trying to commercialize, then you will start seeing a lot more opportunity to commercialize. And they may not all be in the same company. It ends up becoming multiple ventures that needs to be created. So there is this challenge of, again, becoming parallel entrepreneurs rather than serial entrepreneurs. So this is, again, where you get this difficulty about, see, there is so much to do, but there is one person who is trying to do all of this, and how do you scale it? So this is where I think I have personally also tried to translate. I have about 5 ventures, and the whole idea about venture studio through IndusDC, this came about to look to see there is a 0 to 1 problem and there is a 1 to 100 problem. And most faculty by their design are really good at 0 to 1 problems. Even if they take it to a revenue, a company that gets to revenue, it's a 0 to 1 problem. And grants and all of that comes very naturally to them. But then getting to a 1 to 100, which really requires putting systems, really scaling a venture, is something that does not come naturally to many of the researchers. And that's what we also see in our research park, where more than 105 faculty founded companies are there. But if you look at how many are really thriving and scaling, that's probably about 10, 15 companies. So which is kind of where we said, can we look at it a model where the faculty continue to be involved, do what they do best, which is develop technology, but build ventures around them. We can't do ventures in all domains. So we picked decarbonization because that's an area that I've been intimately working on, and put in systems and practices so that we can build multiple ventures. So that's what we are. I was the guinea pig. So we built the first company out of my lab, Trigen DC, which is into industrial heat pumps. which I have already attempted once to build and ran it to the ground, completely ran it to the ground by 2023 and restarted it, but in a slightly different mode so that we give up a little bit more control of the company, but with a chance of trying to scale it and chance of other people who know how to build capital, how to build operations, how to build all support structures, whereas the technology itself is differentiated. So we recently launched one of the global first in the textile industry of a 135-degree heat pump. So it's a model that we are trying to explore to say, is it a one-off thing or can we do it with other ventures? The whole idea is there is no dearth of technology available in the country. And I think Abdur in his previous panel also talked about it. But there is certainly a dearth of a rule book for translation. It happens, but it doesn't happen automatically. Each one has a unique set of problems, also a common set of problems. And then, of course, capital. Capital, we always keep talking about capital, but even if I tell you that I will give you all the capital you want, there is still a problem which needs significant addressing, and it has to be addressed only at the root level. And I feel all the roots are in the research laboratories across the country. So that's the problem we're trying to solve, and we're trying to see if this model can be replicated.
Thank you, Dr. Satya. Let's move on. Hi, Nadi. It's nice to see you again. The next question, of course, is for you. I know Axelor Labs has an interesting dual model of funding early stage research and venture spinouts, and you also have a rich history of building and scaling deep tech ventures. So my question for you is, what would you say is your sort of theory of victory at Axelor? And what gaps are you tackling based on this work and your prior experience with Niramai and other ventures?
Thanks, Madhu. So actually, before I came in and started what we call Axelor Labs, Axelor has been investing in deep tech before deep tech became fashionable, right? They were one of the first institutional investors in Nirame, where we were building AI-based breast cancer screening before AI was fashionable. In fact, before people understood what it was, people knew how to evaluate an AI company, and the word AI used to draw blanks when we used to pitch to VCs. Axelor invested in us at that time, right? This was a translation of IP, not from an academic institute, but from a corporate R&D lab. And like Dr. Satya mentioned, right? Corporate labs that are funding build in India for India. We hit a wall at some point in time where it comes to investing in commercializing and market development for the technologies. There is very little funding and appetite available, right? So we decided to take it out, and Axelor was one of the first institutional investors to back us at that point in time. Not just us, during the same time, they backed Sigtupal, they backed Detect, which was another IIT Madras spin out. Apart from that, they shortly after backed KB Calls, which was from ICT Mumbai, right? So they have been backing deep tech startups without having a very focused model, because the intent always was to back companies that also have a significant impact component. And that is something I believe what deep tech startups do, because we are not just making better products, we are rethinking fundamentally how a certain problem can be solved, right? And when that happens, you solve it, like some of the panelists before me have also mentioned, not just for India, but for the world, right? Earlier attempts, and I have spent a lot of time in corporate R&D before, earlier attempts used to be stripped down, low-cost version. Like in the first decade of this century, everybody was focused on, can we build a low-cost PC, low-cost printer, low-cost whatever, low-cost mobile. And they used to be stripped down. This feature is not needed, that feature is not needed. But deep tech changed that, where we said, for example, in Nirame, what we tried to do was to say, if we need to make breast cancer screening affordable, we don't need a low-cost mammography machine. We need to rethink how the setup in our country is, how women in our country are, what will make them comfortable with technology, and what kind of technology it needs to be, right? So we have to have that very different thinking, and that can only be done through deep tech, is what the fundamental belief always was. Since then, of late, we have also carved out a dedicated fund called Mycelio, and we have funded from IIT Madras, Nutrace, ePlane. We have also backed Novo Technologies, right, which has kind of not from India, but from a US-based academic institute. IP is what they are believe. So we have kind of been backing. But when I came in 2020, the thinking was, that we see a lot of researchers who are doing phenomenal work, but when they come to a VC fund, they see value in the idea, but they don't see an investable startup that they as institutional investors can fund, right? And that was the challenge, that was the gap that we were trying to solve for, saying, great idea, we would love to back it, but in the way, shape, and form it currently is, right? A VC will really, really hesitate. So, what can be done to take this IP to the point where it's truly an investable startup, right? So, with that, we started Exilor Labs in 2020, and I'm hearing a lot of different opinions, but in my own personal experience, even in 2020, one of the top academic institute in the country, when I went and I was talking to a researcher, they were like, we worship Saraswati, we don't worship Lakshmi, so go away. But that has changed. That has changed significantly. Now, a lot of researchers see the value of not just building it, right, but also taking it to the point where it truly reaches people who can benefit from the technology and they understand the role capital plays in reaching to that point. So that has changed in last 5 years, and I'm very thankful for this. Without that, I wouldn't be doing what I'm doing. So yeah, so we decided that at Exilor Labs, what we will do is we carved out a separate fund. We said we will not use the same funding criteria that we use for other investments, right? We learned not just we have to ask different questions. We also learned that sometimes we will be the people who will be answering those, right? For example, one of the very big one, and that goes to what you talked about, theory of victory, is sometimes the team is not complete. Sometimes you see a great researcher, sometimes you do not see a great CBO. So what we learned, one of the things that we built into the model is to not ask them that, where is your CBO? Who is your CBO? Right? And we said, let's walk some distance and let's find a CBO. Instead of saying, founder, you need to go find a CBO for us to invest, we said, give us the permission that together we will find the CBO, right? So we made a lot of changes in the fundamental model that we use to invest at Exilor for the companies that we do under lab, where we curate them. We say, we take it at a proof of science. In fact, we say that science risk is the only risk that we do not take, because we are not scientists. End of the day, we are not the right people to be able to take this science risk, but we take every other risk, is how we look at how we do this. And from that point on, we see that the R&D team that we are betting on, right? We see that they're like commando teams. Their job is to go and crack open a problem. They have to be fast at it. They have to be best at it. They don't have to be most efficient, right? They don't have to be kind of running the cleanest operation that is possible. That is about building the army, which is the org building, which is something we said we will come and we will do together with the researcher, right? So that's the approach, that's the mindset that we went in with. And a couple of points that we do. One is we try to back exceptional founders, not founders who are doing things 10% better, but either the founders who are doing things 10 times better, or they are doing things that have never been done in the world before, right? Not that I am building this for India, or it is this model that works for Indian population, right? But doing things that nobody attempted or nobody succeeded before. That's one thing that we do. Then we let them do what they're best at. We don't say, basically, a lot of VCs try to measure fish by how fast they can fly, right? So which means we don't chase them, where is your MIS, right? We don't tell them that give us projections or build the AOPs and all those things. We realize they are not best at that, but create space, give them time to do what they are best at, and just that, right? That's the only expectation we have. So what we do to do the rest is we bring in co-founders with complementary skill, and we take the responsibility of finding. We play the role of that co-founder till the time we find that co-founder, right? And we define inflection points. We think years of investing, years of having seen multiple successes and multiple failures, we have some organizational knowledge that we can define that for this idea to succeed, these are one or two, ideally not even three, things that they should work on. And if they crack that, that's it. The rest of the things can be figured out from that point on. Define those inflection points for those research ideas. And like it has been said before, Nat also said that build in India, but build for world. Build things that will have multiple use cases, build things that will have multiple commercialization pathways, because all said and done, at such an early stage, the risk is disproportionately high, right? We need to have multiple strategies for us to be able to have a better shot at winning, because the shots are so slim, but we want to take those risks, but we want to also maximize the chances of success. So we try to support platform technologies, right, which allow us to take comfort in taking those more risky bets than we usually take, on any other VCs also usually takes. One of the things that we also do, which I think we are the only VC in the country who does that, is we write grants as a funding model. Because the whole idea is, it's a grant, take it, no questions asked. If you fail, you fail, right? But if you succeed, then we have the right to invest. It gives them comfort that if they succeed, there is also a commitment to invest, right? And for us, it gives a comfort that if it fails, we are not stuck with a lot of overheads, and the founder is not stuck with a lot of overheads that they have to do if they have incorporated a companies. So these are a lot of things we are trying to do. We call ourselves a startup because a lot of these things are also experimental for us as well. But very proud of the companies that we have created while going through this process, and truly enjoying the process as well.
Thank you, Nidhi. I loved a lot of what you said, and I have a lot of thoughts, but maybe all of that can wait. Rahul, let's move on to you. Industrial 47 is specifically focused on building sovereign deep tech companies, which include some new era climate innovations such as nuclear fusion, carbon removal. Could you speak to the problems you're addressing for founders, and how, in particular, global talent and policy are such like major areas for growth?
Okay, that. Hi, first. Good
Hi.
evening to everyone. But that's a multitude of questions in itself. So we focus on what I call industrial resilience fundamentally, national security and industrial resilience. And for me, one is very heavily linked to the other. So we do defense and we do energy. I don't use the word climate as much. The two sectors which until recently were thought quite easily on the opposite ends of the spectrum. People who looked at defense didn't look at climate. People who looked at climate didn't do this. The way we decided to go about this was specifically from the energy perspective, and because we focus only on frontier technology as we believe it to be, nuclear was the one option that we honed in on. There's been recent announcements of a certain amount of opening up of the sector that's been publicly announced as well. So there's a lot that's going to happen. There are the ambitious targets, etc. But I think it comes down to two, three things that made us decide why we want to spend a fair bit of time on nuclear versus A, B, or C as other energies in many ways, and very specifically in the context of India, particularly more than anything else. So one is it's a fairly clearly well-known and understood phenomena that baseload energy replacement will only happen with nuclear. So you can keep bumping up capacity as much as you want. Just for a certain amount that's required, you will have to build it out. There is just literally no other option that exists. So there's a clear directional trend towards it. Second, I think the level of alarmism that had grown up around nuclear energy specifically has significantly gone down in many countries, and enough countries are also steamrolling objections to it left, right, and center in many ways, because we've realized that the trade-off is much worse, right? We keep thinking of, okay, burning coal and climate, and we think about it, but we don't think of the acres of fly ash lakes that get built just by virtue of doing all of this, right? So there are a lot of other impacts that come in. We're like, okay, maybe in this trade-off balance, it fundamentally makes sense. The other reason why I think it's particularly important to focus on it, so I spent a lot of my space specifically in space as such over the last 6, 7 years. A number of my companies adjacently address climate problems through Earth observation and a host of other things like this, marine observability, etc. The choice of the sector for us as an investor was specifically predicated on what are places where we think there are sort of 3 or 4 things coming together. One, is there enough talent pool that exists that has the fundamental ability to do something in this space, even if this were to happen? The second is there a broader shift that we are seeing happen? And now it's very difficult to get that shift right. You could have said the Indian space sector took off in 2011 or 2014 when Team Indus raised $35 million, but that was a bit of a false start, which started 6, 7 years later. So the second bit is a little hard to sort of time and underwrite. But the first is much easier to see, which is where do we have indigenous sovereign talent pool that exists that is exceptional at engineering in the real world. And the two sectors that always stood out to me were space and atomic energy. And by virtue of the fact that we had to indigenously build a fair bit of this technology. Of course, there were technology transfers that happened, lots of nations who helped us as well. But we built a domestic supply chain plus industrial base to be able to attack it. So even, for example, ITER, which is the global fusion project, roughly what 9% of that is being contributed to by India, and it's all primarily in-kind contributions, and it's mostly on large-scale mechanical structures that we are doing that are getting built out here. So there's actually a fairly large supply chain that exists for all of these things in India. In fact, very funnily, if you look at our nuclear reactor fleet, so the concept of leapfrogging is very exciting for a lot of people, but we haven't thought about it as much from the nuclear fission perspective. Most of our reactors are Gen 2 reactors, primarily as a function of the legacy of where we ended up getting them. We actually don't have Gen 3, 3 plus reactors. We're straight jumping to Gen 4 reactors. That's what we are now starting to build out. So we're actually seeing a leapfrog like this happen. And I think maybe 10 years ago, we'll look back and be like, oh, wow, that's when the geo movement ended up happening. So I think it was a conjunction of these three, four factors that made us focus specifically on nuclear and why we decided it made sense. We made a bet, an investment in a company last year, yes, called Pranos Fusion. One PhD, one computer scientist came out to build this, spin off some of the research work that they'd done, and then narrow in specifically into tokamaks fundamentally, or spheromax, closer to it as such. So that's how we chose nuclear fusion. Our decision to back the particular company, and I think this is one of the things where I disagree with a lot of people on when they end up thinking about deep tech innovation. And while hats off to Professor Satya's colleagues, the folks that Axelar has funded as well, it's still a big question that comes up, that what kind of outcomes can end up coming out of research that gets spun out. And what I mean by that is not in terms of, hey, will a business get built or a company get built, but again, very specifically looking from venture perspective, can a very, very large company be built? And one of the things that I've come to understand around that is the function of the large company being built most is is highly correlated with the founder of that company more than anything else, whether they're starting out in a technology or not. I was looking at something recently, and it's very funny. So Zomato, which was considered a Yelp competitor, I was reading one of their memos from 2014, and it was said, oh, we're investing at $200 million valuation. Yelp is 4 billion. The market's great. I looked up Yelp's current market cap. That's about $2.5 billion, while Zomato is about 10x of that. Goes to show fundamentally that what a founder makes out of a company over a period of a decade is very different from it. So at least my take on spin-offs from research labs fundamentally is, I think a lot of them are great mid-sized businesses. And I don't actually think that venture capital might even be the right asset class to do something like that, given the way we end up thinking about portfolio construction. I think maybe what Professor Satya is doing at Indus DC makes a lot of sense for spin-out ventures, because inherently to me, outside of that founder, I think what differentiates a $100 million company from a $1 billion company is generally the founder mindset and not necessarily the underlying technology that exists around it or behind it as such. And there are a rare few individuals who end up thinking on that. I still don't have the answer as to what's the archetype that ends up doing things like that. I've seen enough examples of it now, but increasingly hard to. So at least for us, whether it's energy investments or defense investments or this, it fundamentally goes back to being able to work with exceptional people more than anything else, because this is one of my favorite things. Very early on, when you're studying mathematics, you understand y is equal to mx plus c, the equation. The underwriting for all of venture capital fundamentally is underwriting on the M and never on the C. I will agree also with Nidhi, by the way, that underwriting science risk is not something that VCs should do or would do, or something that we would do outside of maybe one or two complete outliers that we end up doing. Ideally, I prefer that there is only one miracle required for this company to become incredibly big, as opposed to three. And generally, when you throw in science, founders, and engineering into the problem statement, that's three miracles. So we avoid trying to underwrite that. So that's how we end up thinking about it. That's why we're fairly bullish on nuclear. I think a lot more will become clearer over the next year. There's massive amounts of opening up that is possibly slated. So we're quite excited about it. I think when we started talking about nuclear a year and a half ago, we didn't even know, like, when the company was being registered, what do we register this under? So it was registered as a plasma research company because that's what we were fundamentally doing. To a place now where I've just found out that there are apparently now 5 fusion startups in India. So I think there's a fair amount of energy and excitement that people are looking to solve this with, and we try and at least take the more let's be energy abundance approach than carbon and climate change is going to kill us, which it will, but yeah, so I shouldn't be saying these things out loud. But I will stop at that. I hope I've managed to address that question because there were multiple layers, but happy to double click on any of that.
Yeah, thank you, Rahul, for a super interesting perspective. In the interest of time, I'm going to move on, but I think we can come back towards the end of the session. Maya, it's really nice to see you again. My next question is for you. So Green Artha invests in innovative companies, across the breadth of various sectors, and you provide support through different models of investments and partnerships. And I'm curious to understand, could you share a little bit about like these solutions? What made you want to intervene at these different stages and just like the thinking behind, those choices?
Absolutely, Mridu, great to be here. And I will say that it's a Bharti, I'm sorry, but you're coming after me. But it's very tough to come kind of in the second panel after so many different people have spoken because so much insight has already been shared. And so I'm going to try and be quick and, in the interest of time, just talk about what we do at Green Artha and try and highlight stuff that other people have not already talked about. So Green Artha's work sits at the intersection of climate finance and climate innovation. Our focus is industrial decarbonization. And so we really look at spaces and ways to decarbonize India's rapid economic growth. Specifically, the areas of interest to us are energy transition and including within that industrial energy, built environment, alternative materials, and green chemistry. And the reason we've selected those specific areas is because we were looking for kind of the intersection of the Venn where there was this strong growth possibility or strong growth trajectory in India, given where we are as an economy, and an openness and a propensity to working with innovation, which also is to some extent a reflection of the fact that there's a lot of new build happening. Unlike the West, we are not retrofitting. In most cases, we are building from scratch. And so we do not have to wait for legacy systems to grow old and be replaced. We can actually put in more efficient systems right from the beginning. And the kind of the existence of what we see as great frugal innovation in India. When we started off at Green Artha, we did a little bit of a landscaping to understand where is the market and where are the gaps, because that's exactly where we wanted to play. There's no point in sort of replicating or duplicating other people's work. Several panelists have talked about this before, so I'll just very quickly highlight big clustering. What we were seeing is that there is a lot of companies kind of in the TRL 1 through 3, 1 through 4 space, and then just a handful of them that kind of make it across to TRL 9. And that is also was aligning with at the early stage, you have incubation, acceleration support, you have a little bit of funding that comes in, you have great grant support from kind of the government, you have some angel funds that come in. And then closer to TRL 9, you have obviously your customers. And then you also have some of the more sort of established funds that are willing to take you on. Gap in the middle, people have talked about it already, the valley of death. What we were really seeing as a missing piece over here is what we call fit for purpose capital and fit for purpose commercialization support. And the reason I'm saying that is because for the sectors and the spaces that we work, and we are most excited about what we call unsexy spaces with B2B kind of business models, there isn't a lot of existing commercialization support for innovators. These are people who very often have come with deep technical know-how, but moving from lab scale to small batch production to continuous batch production, figuring out your supply chains, figuring out how you can actually tie in all of those from kind of a pricing volatility perspective, thinking about how you integrate with large industrial or enterprise customers and really speak to their problem solution or their problem set, which is not always about the technology, but very often about the output. What are the issues around maintenance and downtime? Those are things that haven't really been thought through very often, that founders don't get a lot of help around. That's what we call fit for purpose commercialization. The other piece that we see is very important, several folks have called this out. I think, Rahul, you called it out as well, that not all businesses are the right types of businesses for venture funding. VC requires a certain type of, or the VC, the way it is played right now, it requires a certain type of business model, a growth trajectory, your hockey stick. And there really isn't a lot of space for companies that have assets, that have plants, equipment, and machinery, that have some of this more linear growth model, but could also just be very solid businesses that continue to grow year on year. And so this is the other space that we like to work in. We like to find different types of climate financing models that will really speak to different business models. One of the things that we did early on, and I'll wind up here and hand over to Bharti, is that we set up India's first venture philanthropy fund for climate and environment, because we really saw that there was a need to provide a specific type of, to the point that several folks over here have made, including Nidhi, to provide non-dilutive capital to for-profit companies, because they are at a very specific inflection point. They need certain things to unlock and to unblock their growth. And that the market is not going to support. Customers are not going to support that, and VC funders or commercial funders are not going to support that. But once that happens, the market opens up and they are ready for commercialization. So we set that up and worked with a bunch of companies through that. We are setting up, or we have a model for what we call structured equity, which really takes a blended finance model, looking at how you can layer in equity to de-risk what is perceived as additional or higher risk with certain types of business models to enable commercial capital to come in earlier. So I would say that really these are the things that we do, and the reason we do them is because of that gap that we identified right in the center of the market landscape.
Thank you, Maya. I love the fit for commercialization piece that you mentioned. A lot to kind of double click on over there. But moving on, Bharti, it's really nice to see you again. My last question for this round is to you. Momentum Capital has a very interesting thesis focused on scaling Indian talent and companies for global markets. And so my question is more about what has been the genesis of this idea? Do you think global markets are necessary to scale deep tech and climate tech solutions? And do you think that there's something special about Indian talent that scales globally? I know this is also quite a layered question, so feel free to pick it apart, or also, take it on one by one.
Amazing. Thank you, Mridu. Great seeing you again. And yeah, as Maya said, it's a tough act to follow. But so let me start with the thesis for Momentum Capital and then try and answer your questions. So we, as you rightly said, invest in Indian talent, whether they are in India or outside India, North America, Singapore, etc., who are building solutions to solve tough problems for the world. We try and look for companies that have a fundamental innovation, right? Quite similar to what Nidhi had mentioned, that they are doing something breakthrough, which can be the best in the world. And that breakthrough might be in terms of, doing something that was never done before, or doing something at a much lower cost that was never done before. Now, to answer your question around, do you really need to have global markets? So we do believe that, given climate change is a global problem, it does require global cooperation to solve it. And each company that will try to come up with a solution might go through a journey where there might be some markets that are attractive to begin with and other markets that will become attractive later on. And a lot of that has to do with the policy landscape, since, the world of climate change is also very highly influenced by policy. And to give you an example, maybe, we can look at, say, battery energy storage systems or green hydrogen, right? A few years ago, US was probably a great market to be building a green hydrogen solution, right, with the IRA. But that has changed now. And so we invested in a company that was building a solution for the green hydrogen market for Europe, but now it has for the US, but now the focus has shifted to Europe and even India. And so we do think that if you are building a great platform technology that is best in the world, you will have to be agile and move with a little bit of where the market is. We also see great companies who are now building solutions for, say, green hydrogen for the Indian market, because there is now growing demand for, say, green ammonia, green hydrogen projects in India, and we're able to do that at much lower cost without subsidies that were needed in the US. And so in that sense, it's not necessary that you need to go after a global market, but because geopolitics is not in our control, you do need to have the ability to have global access, and we feel that we can be great partners for the startups while they do that. Yeah, I guess I'll keep it short, and we can come back to this.
Thank you so much, Bharti, and thanks to everyone for a great first round. I'm now going to move back to Dr. Satya, and for this round, we're going to have a more general theme of just, we hear a lot about valleys of death and the risks with funding deep tech and climate enterprises, and especially funding for building first-of-a-kind facilities. So coming back to Dr. Satya, you've seen both sides, and we'd be curious to understand, why do you feel financing climate innovation is so risky? And could you maybe, through way of example of spin-outs from IIT Madras or Indus DC, sort of illustrate what these risks look like?
There are two challenges here. One is there is the TRL3 where the science problems are solved. Then the TRL6 threshold where the engineering problems are solved. Now, solving engineering problems can be very frustrating because it has a lot of sunk cost, meaning you start with something, it works, and you know that it works. So those problems are the hardest to give up because the promise is really, really large. So when you take up, say, nuclear fusion, for example, that Rahul just mentioned, the promise is immense. But then to solve that engineering problem, it keeps coming at you. And we have personally faced that. The company that we recently got invested, Bankel Energy Systems, was a very simple problem which says industrial steam is 20 gigawatt of untapped potential in India, which is not taken by anybody. Why is anybody not taking it? Because the turbines don't work. And within 2 years, it gets eroded. So that's the simple premise. We got a DST funding, started building the product, and worked in the lab. Even as of yesterday, we had our field deployment fail. What happened? Some seals failed. And this is something where when we took on the money from the investor, we said by October, we will have first pilot unit running. And by December, we will have 3 orders. And by March, we will deploy 6 units. I'm doubtful even if we'll deploy 2 units. So this is where I think there is the disillusionment phase. And it's a tough thing to solve because now when you have invested venture capital funding, unless and until you understand how engineering evolves, this is a problem that you can't understand. Why can't you ship faster? Why can't you solve it? And sometimes you just need to sit with the problem. You can just not, you can throw enough money and enough people at it, it won't get solved. You just have to sit with the problem. And one of the theses at Indus DC is precisely that. Now, don't take venture capital money if it is not needed. Try other kinds of financing and only take investment when you have repeatability in your revenue. So we actually take our first institutional round only when I have $1 million revenue, which means I have deployed a couple of pilots. I know it works. I have solved the engineering problems. I'm on to my supply chain problems. It's only when the problem gets de-risked. And if you take funding, which is non-patient capital, any earlier than that, it becomes really, really difficult to solve. And I think you can see that in multiple areas, right? Right now, Satya Chakravarti, the other namesake of me, who is on the sky and I'm on the ground, he's also going through similar kinds of exercises. And when the Air India thing happened in Ahmedabad, there's suddenly a hold on all DGCA kind of approvals, even though it was something else. So you need to de-risk, and de-risking can take time. And I think we just have to recognize it, and we need to have that kind of VC. I'm really glad that Nidhi talked about it, but we need to have that kind of VC. And it's just that's the nature of the beast.
Thank you, Dr. Satya.
Dr. Satya, sorry, Mridu, if I may add one thing, and
Sure.
I say this to everybody who decries this, I 100% agree with you that this requires patient capital and people understanding it. But one of the things I tell people who do consumer investing, etc., is specifically that it's not that consumer outcomes have actually happened faster. all of those companies have also taken literally just as long in Indian markets to actually get to what are sizable outcomes. And that's one thing I hope if there are founders who are listening to this or thinking about this, do not get dissuaded by it, that anything incredibly big and large and impactful takes a fair bit of time, whether it is going to be a stockbroking company that you build, a food delivery company that you build, or a climate energy company that you decide to build. So while the sector sounds painful, the others aren't much easier either.
Thanks, Rahul. Maya, I'm going to skip over to you. And I know you spoke about like different capital stacks and patient capital in the previous round, but I think this is an opportunity for us to dive a little deeper into that. Could you talk a little bit more about like what you see very specifically as the role of patient capital? Can you talk about how it is structurally different compared to, traditional VC models, and especially to finance deep tech, right, and climate? Maybe just a couple of minutes on that, and then we can,
Yeah. I'm
continue.
cognizant
Yeah.
of the time, so I will be quick. And
Yeah.
I think I've
Sorry.
also,
Yeah.
no, I've been helped along by the fact that I think Dr. Satya also has already answered like most of the question, but I will try to like quickly tie it up with a knot. So very clearly, the types of businesses that we look at and that most of the people on this panel are looking at have different growth trajectories, different types of business models very often, because if you're selling something that comes into the customer as a capex, that has a very different way of landing than something that is getting sold, let's say, as a SaaS product. And these have, different types of, as Dr. Satya was saying, different types of de-risking that are needed. Now, that de-risking is really not something that, again, VC has been very comfortable to do, because traditionally how we have seen VC play out, at least in the last, I would say, decade or so in India, is very much with a focus on platforms and on kind of either consumer or SaaS models. And so they are used to those types of business growths and business trajectories. But building out, as I mentioned earlier, hard physical assets has a very different way of growing. I mean, and also requires different types of modeling and de-risking, because there are real risks associated with integrating something into a system versus putting out a software product that maybe has a bug in it. And so the type of capital that is needed, which is also why we have been looking at the types of funding that we have, all have different return expectations. But this is why we see blended finance as being interesting. Blended finance is a nice hot topic, and everyone talks about it. But really, what we see is that there is a role that concessional capital can play in specifically coming in to de-risk the additional risk. Now, it should not de-risk everything. That's the role of the VC. That's why you have a risk return profile. That is why you are doing your own underwriting as a standard commercial VC. You should be able to see some risk, and that is the return that you get on the base of the pricing that you do of that risk. But there is some additional perceived risk or real risk that the catalytic or the concessional capital can come in to essentially resolve. And that was the work that we were doing, for example, with the venture philanthropy model. That's why we are also looking at a structured equity model where the two of them can actually play together, with the end outcome being that commercial capital comes in and comes in earlier, because that's also the earlier it comes in, the more value they are able to accrue as the company grows, but it also enables the company to grow faster. So that's really, I would say, very quickly, the role of patient capital and why it's important for this ecosystem.
Thank you, Maya. That was super detailed, thorough, and yet quick. Rahul, I'm going to circle back to you. Just sticking with the theme of patient capital, you've worked with entrepreneurs in frontier technologies, areas like nuclear fusion. You also mentioned space tech, even before it became popular. And I'm curious to understand, do you feel that the capital requirements and stage gates for these companies are fundamentally different? And if so, how do you see them being fundamentally different?
So, um, if you're thinking fundamentally different, I disagree. In fact, that's maybe a lot more truer of a place like the US. And I think this is one of the questions that's here as well. So I'll address that. The fundamental cost of talent in India, and exceptional talent, is um, I don't know, underground on many levels, if you end up thinking of it. Just, I'll take the example of Pranos itself. The kind of talent that they've been able to get, and for the kind of, in some ways, cost base that they've been able to accomplish this, it is incredible. There are scientists who've come back from abroad who are most probably on salaries that an IITian or a BITSian would not want to think of as first salaries. And these are people with like 10 years of experience who've come in. So, in fact, what I've actually seen is the talent pool that ends up working in this is extremely motivated by being able to do this kind of work, something which is not available in India anywhere outside of government facilities and government labs. Like until maybe 5 years ago, 7 years ago, you could not go work on rockets outside of the ISRO. Until a year and a half ago, 2 years ago, there are so many things you couldn't do, and this is across multiple sectors. So, for the kind of talent that's actually drawn towards solving a very hard problem and being excited by doing that day in and day out, there is for the first time another opportunity that exists outside of just the academic setup. Um, so that allows you to get insane talent. In fact, I tell deep tech founders, and this is one of the things, deep tech companies, even with tiny amounts of money, just refuse to die. There's a robotics company that I know of that raised their last round of capital in 19, and they're still alive. You will never ever hear of a consumer company going out and being able to do this as such because they generally end up being small, lean teams. Um, so that's one. Second, if you do capital comparisons, and I have a interesting case study for this. I invested in two companies simultaneously. One was a fintech company, and the other was a space company. And over the next 4 years, they both roughly managed to raise the same amount of capital, but at differing points of time. Consumer company raised a lot of money, then burnt that. The other company kept raising it. Funnily, the kind of cost that these guys had on customer acquisition was in the rough order of what was cost for capex that the other company had. And it was pretty insane if you think about it. And their cost base was again cheaper because you want to hire a good product manager in India, they're very expensive. You want to hire a great aerospace PhD grad from IISc, um, inexcusably inexpensive on many levels. So I think there's a insane delta. Just to give you an example of Pranos Fusion, we seeded them with like you would think fusion company are like under $10 million, we can't do it. We seeded them with $400,000. And the idea was that the best founders find ways. They're like, okay, we're going to find a wedge. We're going to do plasma simulation. We're going to figure out this is the wedge. This is what I can solve. This is what I can solve with this team. Get it here. And in India, you actually can. So you want to go hire a cracked electrical engineer coming out of a Purdue or a Stanford or a Georgia Tech. You're going to pay anywhere between 80 to $100,000 for that person. You get the best electrical engineering grad coming out of any of the top colleges in India, or even with 3 to 4 years of experience. You get them on like a 20 lakh LPA. So, what would be the salary of literally three people for a company like this abroad is effectively a seed round that can fund you for 2 years. Um, and I think it's incredible. These are all the reasons I'm insanely bullish on building deep tech in India. And you can see a lot of these primitives coming about. 6 years ago, I wanted to get any level of precision manufacturing done, or like things that you would, for example, require like a 5-axis CNC to do these special cuts inside. You couldn't find a company to do it. Now there are 6 startups doing it. It's a little hilarious. Well, positively so. So there's a lot that's moved, and hence, even with small amounts of capital, there's actually a lot that can get done. And I think investors have started to build the risk appetite for this. They've started to understand what is potentially de-risking. I, in fact, think the ecosystem swinging a little too much where um, there's this how do I say when a consumer fund says that we are now a deep tech fund, your market is a little frothy in many ways. So in fact, I would say a lot of these companies are getting a lot more capital than they would even require. Like what would require a $5 million pre-seed seed round in outside of India is something that can be accomplished within 500 to $700,000 in India. And what's the other insane bit is government facilities from what I've seen in the last 3 to 4 years. And honestly, everybody points to one direction when you ask them about how in universities have opened up, and they point to IIT Madras and say how it's been sort of the flag bearer, the template holder in many ways for how it's been done. Like I was just talking to another company which was able to work entirely through the pandemic because they was incubated at one of these institutions, and they got engineering work done for a year and a half while all their other competitors literally couldn't move elsewhere. So it's also insane what the academia and the government institutions have now opened up. It's really like open season. They're like, please come do it. And I think Professor Satya can maybe attest to it. I don't think that was the case a decade and a half ago for sure.
No, certainly not. Things have certainly changed, and I think there are other things like IP policy have also been so liberal. It's not the question of erecting walls, it's just the question of saying, first get it done and let's figure out what happens next.
So incredible time to be building. So if you're thinking of building, please do. But outside of this, I just wanted to address something that came up in Q&A, which is just this LinkedIn post and this whole dumb money is doing nuclear bit. And since it's here, it's best to address it. Um, the gentleman who's written it out is fairly smart. There are fairly strong arguments for why this works as well. There are, however, a few very clear arguments why this doesn't make sense. One is just global, just the amount of capital that goes in. So if you asked anybody about solar photovoltaics in the early 2000s, they would have laughed at your face. In fact, there's a whole case study on VCs investing in solar concentrators for 5-6 years between 2008 to 2012-14 because they thought solar photovoltaics are such an outlandishly bad technology that it makes no sense to ever use them for anything. They all lost their shirts. And all of them pretty much shut down as such. So, one, I would bet against fundamentally saying, okay, is there more money that's going to come into this that allows for things to happen? And assuming that that is how it's going to be. There's semiconductors, large parts of aviation, large parts of jet gas turbine engines. All of these are rife with, oh, this makes absolutely no sense on any level, which have gone on to underpin fundamentally what has been our world. So if I were to say, oh, this isn't going to work just based on something that was done 25 years ago and done badly at that in decade supply chains and use that as an example for today, it's a straw man at best and I think a disservice to humanity at worst. So that's at least my argument against it, and it's very clearly seen out how it works. So just saying, oh, tab nahi hua tha to hum nahi kar sakte. Great, doomerism max. We should do that.
Thanks, Rahul. Thanks for all the examples. I think that really brought a lot of your points to life. I'm just wondering, Varun, how many minutes do we have left before we wrap up the session?
I think like 3 or 4 minutes max. Yeah.
Okay. So I'm wondering if you just sort of skip to the last question in the interest of time. Okay. Again, super sorry to be doing this. We're gonna have to skip a couple of questions. But just to like wrap up the session, want to end with a question that is, I think I would say more inspiring. And this is for all the panelists here. The question is, what can we learn from adjacent industries, including defense and space tech as they scale? And if you could share like one specific thing that you think we can learn from adjacent industries. And the second part of this question is, if you had to wave a magic wand and change something, one specific thing about the climate innovation ecosystem, what would it be?
I'm happy to
And you
jump
can,
in.
yeah.
And I'll be very quick because I'd like to hand over some of my time to Bharti. So I'm just going to respond to the second one. I've talked about this before. Innovation in climate finance is, I think, really very important to build out the capital stack and to extend the capital continuum. So with that, I'd love to hand over to Bharti.
Thank you, Maya. And I think I'll just answer the second question, which is if we had a magic wand, what would we do? I think, and some of that is happening today, which is more cooperation across technical and business talent, cooperation across institutes, startups, and industries, so that we can actually avoid some of the valleys of death, avoid some of the mistakes that maybe the West has made, where we can actually come up as our Indian culture does require cooperation, and we can use that to make the climate story a success for India. Maybe hand it over to Nidhi.
Thanks, Bharti. To first question, very quick response. The role that the government plays in unlocking both the innovation and the market, and that holds true for health, basically biotech, where I have worked a lot in green chemistry, you name it, right? All the areas it holds true for. If I had a magic wand, I would make Indian industries, the large industrial players, open up more about the innovation that is being done on the ground by Indian startups and made them more open to the idea of adopting them and trying some of them out, because that has been a major difference between the climate that US startups and Indian startups see. So I wish that would change. With that, Dr. Satya, over to you.
Thank you. I would simply say put in clear cutoff dates and say by this date, beyond this date, you can't do the old stuff anymore and only do the new stuff, and automatically things will fall in place.
I'd say if I had a magic wand, I would do two things. One, I think um, I'd stop a little bit of this, and again, I'm not as deep into the climate space as you folks, and this will be fairly controversial. So apologies in advance itself, but I I wish, and I say this across broadly deep tech as well. I wish we stop cribbing about, hey, this is not the best way to do it, or that is not the best way to do it. Uh, it's not people who are working in this space who are the enemies in many ways, and us pulling down. And maybe I'm a little sensitive about this specifically because of the nuclear thing as such. Because I would rather be a lot more appalled to the money that's being spent on, say, I don't know, apparel and things like that in this world. So I say this to other VCs as well. People have asked me, oh, is this deep tech VC or competition or that? And I'm like, no. My competition is every consumer, direct to consumer VC in this country who exists, because capital pool is limited and it's going there. So instead of infighting, oh, I'm best for this, we really need to be working together about this. And I think like it's symptomatic of what I see as a general cultural mentality that we've developed over a large period of license Raj and the economic structures and the social structures that we operated within this country as such. But I really wish we could wave that away, because I know I can't, and magic will take it. The second is, if we can spur more spending on R&D from Indian corporates. It's a very sore point. Our Indian government spending on R&D is actually similar to, as a percentage of the GDP, to a South Korea, which is a global leader in this. But it's almost a 16x difference between what the Indian private sector spends in R&D versus what the Indian what the South Korean private sector spends in R&D as such. So if I could suddenly wave their minds to be like, please put in more money into actual R&D, I'd love for that to happen.
Thank you so much. You all have been wonderful. I think I'll hand it back to Varun to wrap up the session.
Yeah, thank you so much, Mridu, and apologies to everyone that, I mean, honestly, this could have been a 2-day conference in and of itself. I realized about 10 minutes into it that we had under budgeted for time, but thank you so much, Bharti, Maya, Dr. Satya Seshadri, Nidhi, Rahul, and Mridu for this session. I mean, honestly, really inspiring stuff, lots of food for thought. I think we've been talking in the background about potential models we could take forward together. I'm hoping that there's something by way of collaboration this group can also do. So if you're open to it, we'd love to reach out. And obviously, if you stuck with us in the audience as well, please reach out to these folks, especially if you're founding, scaling, want to join their organizations, etc. And even if you're in research, corporate R&D, all of that stuff, right? I don't want to take a lot of further time, just to let everyone in the audience know. And if you're watching this on a recording later, we will definitely be following up on many of these items, summarizing them and sending them out. And you can see more from us in this area. You'll have noticed, if you saw my slides at the beginning about 2 hours ago now, I didn't include a venture strategy slide. There was nothing there. It was only something about science and something about policy. The reason for that is because we're learning through conversations like this what we would like to do to support the venture ecosystem. And there's obviously excellent people already doing work in that space. So we want to be only differentially impactful if we're going to do work in that space. So thank you so much, everyone, for sharing your insights. We at ICI will certainly be following up to learn more and to collaborate on many of these items. So I'll call it to an end here. Thank you, Shardul, as well from ICI for all of the technical coordination in the background. Take care, everyone. Have a good evening.
Thank you.
Thank
Thank you,
you.
Thank
Varun. Thank you,
you.
Shardul.
Take
Thank you,
care,
everyone.
everyone. Bye.